Dear students, welcome to this three-part video series on testing. This will be split up in testing in general, a bit of information about the terminology on testing. I think that some of those things might already be familiar to you. And the second video will be about unit testing with Jest and unit testing in Vue.js, also with Jest of course. And the third video will be about end-to-end testing with Nightwatch and possibly Cucumber if you want. Now, this is what I was basically talking about right now. Testing in general. So you might already know that testing is important. Testing of your code gives you a good feeling that nothing should break and everything should work. Now, when we talk about tests, there are a lot of terminology like the different types of tests, for example. So tests can be split up into automated tests and manual tests. Manual testing is what each and every one of you is doing when they write some code and then they click through it and try out if it works. These are manual tests. There are also different types of manual tests, for example, exploratory tests, where you let people who don't really have an idea of your project, or testers who have an idea of your project but have no plan on what they're going to test. They just try out stuff and see if it breaks. So that's exploratory tests, but there are also many other types of tests. Now, automated tests can also be one of a few things. So this is not a complete list, but the most often heard terms are unit tests. Unit tests should be small and fast and only test a unit of code. Then there are integration tests, which test if basically some units work well together. Then there are functional tests or GUI tests or end-to-end tests or black box tests, whatever you might call them. There are acceptance tests, which focus more on how something behaves and if it behaves in the way the specification or the users need want, right? And yeah, then there are performance tests, there are smoke tests. Smoke tests are basically just a subset of your tests that tell you if your application is still working at all. So these might be very general tests. They come from plumbing actually, where you pump smoke into a pipe and see if it's if the smoke comes out anywhere. Now there are accessibility tests, security tests, regression tests, and many more tests like monkey tests, whatever. The thing we're going to focus on here are unit tests and end-to-end tests, because those are the ones that you will probably need for your web applications. Now, when talking about testing, people also often talk about this pyramid of testing, which basically tells you that you should have a lot of automated unit tests that are exceptionally fast. Unit tests just test basic functions, classes, maybe interfaces even. They should be really fast and should be very tightly coupled to your code, actually. And these are the ones that programmers usually write themselves. And on top of that, there are tests between components, between APIs, and they're usually called integration or functional tests, yeah, depending on the team and your setup. So these tests test if different units work well together. And of course, now they're a bit slower than unit tests because there's much more to do. So there should be less of them, but they are equally important. And then on top of the pyramid are automated tests. Automated end-to-end tests are the slowest of them because you have to run your whole application and then you have to automate a user behavior like clicking, writing, and yeah, touching and all of these things. And on top of the pyramid, there's manual testing. Of course, there are some things that you won't have automated or that can't easily be automated, and there's always place for manual explorative tests where you find out if there are other things that you might automate or that you can break that are not tested by automated tests. So this is the ideal picture. In many projects you don't have a pyramid, but you have a cone. So in many real-world projects you do a lot of manual testing, mostly regression testing, Regression testing is when you see if everything still works after you've changed something. If there's now a bug after you've changed something, that's called a regression. And in most projects, in most real-world projects, there's too much of manual testing. Then there are a lot of automated end-to-end tests, and often very few unit tests. So this is the worst case. Now, why would you test anyway? Because you're a lazy developer. And when you have a lot of unit tests and end-to-end tests, you don't have to do manual testing, which takes a lot of time and where you can also miss things and forget things. Tests are like a really cool checklist that you can run before checking in your code, before committing your changes. So yeah, lazy developers write tests. Then another thing that's often talked about in testing is test coverage. Now, there are some people who religiously want to have a full test coverage for all of their code. But the thing is that test coverage doesn't tell you anything about how good your tests are or how well your code is tested. Test coverage only tells you which parts of your code have been tested by some test in some form. So I won't give you test coverage that you have to reach in your projects, like 80% of code has been tested. I want you to make an educated decision on how many tests you need. And to do this, I would like you to think about these two things. So it's not a hard rule. So Martin Fowler, which you might be familiar with, suggests that you might have enough tests or good tests if you rarely have bugs that escape into production. So that when you change something or when you add something, there are no new bugs. And you don't fear changing your code. So this is also something that tests can really help you. When you refactor and change your code and you're not sure if it works, then that might mean that you don't have enough tests, because tests should give you the confidence that everything in your code still works and is cool. Now, I've a few slides that I've skipped. There's this really nice, I don't want to say poem. It's more of it's funny text about testing between an apprentice and a master. You can have a look at that. Now, another thing that's often discussed with testing is tools. So yeah, sadly, like with any part of web development, there are many tools that you can use for testing. These are just some of them, like Jest, Nightwatch, Cucumber, and they all have very nice names, like Volkswagen, for example. And this is also, again, not a complete list. So there are a lot of tools that you can use for testing, and this can be daunting at first. So what helped me is categorizing these tools into what they actually plan to solve. So tools can be categorized for once in tools that provide a testing structure. Some examples are Mocha, Jasmine, Jest, Cucumber. They just give you a harness of how you structure your tests. And yeah, this usually is a function like test and then a string for test, this and that, and then a function with assertions. But testing structure might also be how you can group tests, providing tags for smoke tests, for example, and all of those things. So that's the testing structure. Then there are a lot of tools that provide assertion functions. In Node.js, there is a built-in assert, but there are tools like Jai and just Jest that give you also an expect interface where you can do behavior-driven testing, for example. So assertion functions are usually just an assertion is testing if something is true or false, maybe, or if a string equals another string. And with BDD, it's more like this should be that and expect X to be Y and things like that. Those are assertion functions. So the actual tests. Now, then there are tools that help you display and watch test results. Yeah, like different formatters and all of those things. And yeah, watchers, of course. So when you change your code, the tests will rerun, things like that. Then there are tools that provide the capability to make snapshots. So I will get into snapshot testing later. It's basically running your test, making a snapshot, and in the next test run, you compare your test to your snapshot. And if it has changed, then there's a regression. And there are tools that provide you with mocks, spies, and stubs. Those things are called test tuples. All of the fake objects that you want to use to replace existing things. So you, for example, don't call your API, but you only call a function that gives you a static object. And there are libraries that give you this. Now, another thing are code coverage reports. So to get code coverage, of course, you need a tool that logs all of the lines of code that have been executed by your tests, so it can calculate the coverage. And yeah, last but not least, there are tools that provide a browser or browser-like environment. Because the thing with unit tests is that you want to run them in isolation. And isolation means, yeah, it's easy to test pure functions, it's easy to test Node.js modules, but it's not possible to test the DOM or the browser in unit tests, which is why there are browser-like environments that fake a DOM, so you don't have to start a headless browser, which takes time again and slows down your unit tests. In end-to-end tests, of course, you do use a real browser, which you do with Phantom and Nightwatch. Yeah, but they're slower then. Now, as you've seen, Jest is an example that has batteries included, which is the goal of the library that was built by Facebook, so you don't have to worry about getting 3 or 4 test tools to work together. It's really nice to work with Jest. It's making writing tests very fun and easy. Now, again, what's a testing structure? A testing structure might be something like this. So a tool gives you top-level functions like describe, it, test, where you can structure your test. So you might have tests for a calculator, then you might have a few tests for the adding function or for subtraction or multiplication, and then you can do all of your tests, which have assertions, of course. And assertions might look something like this. So basic assertions would be, for example, assert equal. You have a value that your test returns and you compare it to another value. Or you compare the type, or you just check if something is true or false. In most libraries, this is assert.ok, where you can pass a Boolean value then. And expect style, which is more behavior driven, might look more like a real sentence, like expect foo to be a string or expect foo to equal bar. And sometimes there are also functions that make this more concise, like expect foo to be a string and to equal bar and things like this. This is just another style of writing. So there are many assertion libraries that provide the possibility to write assertions, and of course, as with any other part of programming, you should have a look at the API and learn what the library can give you. Now, I've also talked about tools that give you spies, stubs, and mocks. So what might a spy be? A spy is actually a very good name because it spies on a function, so to speak. So here's an example with Xenon and any testing structure library, whatever. Might be Jest, might be something else. So the test is called it should call the method once with the argument 3. So there is an object with a method, and in Xenon you can create a spy that spies on this object. And Xenon will then wrap the object, of course, and log anything that happens to the object, like function calls and what arguments have been passed and how often the function has been called and all of those things. So you can then just call the method, and your assertion might be that the spy has been called with the argument 3 exactly once, and then your test succeeds. Now, a stub is a bit more than a spy. A stub is basically a replacement for an existing function. Not a complete replacement, but a stub in the sense of the English word, that it's just it's not fully implemented, but just the most basic parts, a stub. In Xenon, this looks like this. You can stop the function isValid of the user so that it always returns true. So the isValid function in its original form and its actual implementation might call a library or do something else that is very complicated and not the thing that you want to test in your unit test right now. So you can just stop the function. And you can do the same with jest. This is also how you would create a spy in jest. And in jest, you can do mock implementations for things. In jest, everything is called a mock, actually. But there's no difference between spies, stops, and mocks, but in some libraries there is, which is why I want to show you these three concepts. Now, a mock is similar to a stop and a spy. It's a combination of a stop and a spy. But a mock also has built-in expectations. So here you can see in Xenon, you can mock the whole jQuery library, and then you can build an assertion actually into the mock. So in our test, I expect the HUXE function to be called at least twice and at most 5 times. And then you can verify this. In jest, it's I think it's even more readable. It's in jest, everything is every mock function is built with jest.fn. This gives you a mock function. In the argument, you can also pass a function like in here, or you might also use jest.fn and then later use jest.fn mock implementation. Depends on your style. Then you can expect the mock function to have been called with arguments, to have been called X times, and yeah, things like this. Now, again, the difference between a spy, a stub, and a mock. They are all called test tuples. And there are more things than just spies, stub, and mocks, depending on the library that you're using. And yeah, the community that you're in, the programming language that you're using, whatever. So spies basically just give you information about function calls. Stubs completely replace the function, or it wraps the function and doesn't call it, actually. And mocks are spies and stubs with pre-programmed expectations. These definitions might differ from library to library, but these are the ones that I'm most familiar with. Now, there are other things that testing libraries can give you, which are really cool. So, for example, there is fake timers. Fake timers are in Xenon. There is also a smaller library that has been extracted from Xenon, which was called Lolex. I think it's now been renamed to JavaScript fake timers or something like this. And this helps you test functions like set timeout, set interval, and even the clock and things like that. So what it does is it overrides all of these functions in the browser or in your fake browser, and then gives you the ability to work with the clock. So for example, you can also call this without an argument. You can use Xenon use fake timers, and it will wrap all of the built-in browser functions like set timeout. And then you can use set timeout. This could also be Windows set timeout, actually, in your code, because there's sometimes timeouts in your code or Ajax calls or whatever. And then you can tell the clock to advance. You can tell it to advance a specific number of milliseconds. You can tell it to advance the next timer. You can tell it to advance all timers and things like that. And you can also change your date and time. So if you're, for example, testing if birth date can't be possibly true because it's in the future, you can use fake timers in your test to test this behavior. Now, another thing that you might want to fake are API calls. So Xenon can also fake XML HTTP requests by creating a fake server. And the only thing that you then have to do is setting all of the requests that your fake server understands. So you can tell Xenon to fake get endpoint /users and always return an HTTP code of 200, the content type application JSON, and yeah, just 2 example users. So with this, you don't have to set up a mock server that also has to run in parallel to your tests, but you can just simply stay in your browser. And Xenon will overwrite the XML HTTP request, which you can restore later if you want to make actual calls again. So this eliminates the need for mock servers, which is cool. and also very fast. And yeah, then you can just call the user's endpoint in your tests. In this case, it's it might be it might be an XML HTTP request wrapped in a promise, and you can expect the same object that you had here. And what you're seeing here as well is an example of how to do an asynchronous test. So most libraries will give you a function or a function that you have to call when your test has completed, which is usually called done. So other than that, your test framework doesn't know when your tests have successfully completed, or whether they've completed. Doesn't matter if successful or not. So in asynchronous tests, you usually have to call done to tell the framework when you're done. And yeah, after all of the tests, you can tell the server to respond to the requests, and you can also restore the original XML HTTP requests if you want. But yeah, if you're just in your test framework, that might not be necessary. Yeah, so those are just a few of the things that testing libraries can provide you to write cool unit tests. And then, of course, you also have to care about the browser environment. Now, you could use a real browser, which is also possible, so you can run your unit tests directly in the browser if you want, but then you have to start your browser. You can do it in a headless browser environment, so a browser that has not run its GUI and doesn't render its GUI. Or you can use a fake browser environment like JSDOM. So yeah, JSDOM is a JavaScript implementation for Node.js, and it gives you a window object, a document object, and all of those things that you would expect in a browser, but everything's fake. This is cool because you can then use it in unit tests, and it's actually quite fast. And as you can see, it's also a very popular project. And this is also built into Jest. So when you use Jest, the JS DOM is automatically loaded, and you can test things like query selectors and write HTML and do things on the window and the document, which is cool. So, and that's all for the basics on testing, and in the next video I'm going to talk about unit tests. See you then!